Hi everyone, this is Kamyar Kordari, your host. Today I'm joined by Dr. Ahmad Fattahi, who is a manager of data science at Cisco. Hi Ahmad,
Hi, Kamyar. Hi, everybody.
thank you for taking the time to present to us today.
Absolutely, my pleasure.
Okay, the floor is yours. Go ahead.
All right, thanks. Thanks for having me. So I wanted to take the opportunity and talk about basically, starting and then maintaining and growing a data science and AI process and practice in more mature and established organizations. And in my experience, it is significantly different from starting a fresh company with a idea about data, right in front of your mind. And by the way, before we get into the meat of the presentation, I wanted to say, even though I work for Cisco and at Cisco, this presentation is completely my own personal views and experimentations. It is not Cisco's. So what do I like to convey as part of this presentation? I hope you guys leave with a better understanding of what do we mean when we say data science and artificial intelligence, and also a few tips and tricks from the trenches that sometimes I've actually learned from in the hard way, and what pitfalls to avoid. So we're going to start from some basic definitions like any standard presentation. We talk about some of the basics of how you would start the AI practice, and then we introduce and then leverage this famous CRISP-DM framework to put some structure on your AI practice. So let's start with some definitions. And I'm sure, by the way, that if you Google any of these terms, you can see a million different definitions. So it's not about the details; it's more about the context and concepts. Plus, for the rest of this presentation, we want to be sure that we are all talking and meaning the same things. So by data science, I mean this collection of all of these algorithms and tools, processes, very important as well, as we'll see, that eventually help you move from data, raw data, sometimes libit process data, all the way to value. And then on the right-hand side, what you see here is my definition. I think it's not that I came up with it, but to me it makes most sense that we see AI as anything that applies intelligence in an artificial manner, which is the biggest umbrella, machine learning, and those types of algorithms that extract some pattern from raw data by machines. That's a subset, and then deep learning is a subset of those algorithms that typically involve neural networks and build several layers, hence the name deep learning. All right, so let's start from some fact checking, and I'm sure depending on where you come from, you have seen a lot of and heard a lot of different stories and myths about data science, what it can do, artificial intelligence, ads on TV that somebody shows up at the door and tries to fix your elevator, and you're like, but we didn't ask for it, and the guy says, no, this guy asked for it, and that guy is AI, so it's that smart. So those exist for sure, but in many cases in the real world, if you step out of ads on TV, the stories are typically different, especially in more established organizations. Eventually, you're going to hear from me the V word, value, many times. It all boils down to that. It doesn't have to be fancy. It doesn't have to be cutting edge AI, anything like that. Sometimes it is, but in many cases, especially if you start a new practice, it's going to be so many low-hanging fruits that gives you a lot of value without necessarily using or applying super sophisticated algorithms. And the other aspect of it that I really encourage you guys to think about is, as opposed to solving one problem at a time by one person, if you're thinking longer term, you want to have it as a practice, you want to think about it as a organizational capability, meaning you want to think about bringing up your staff in terms of education. It's going to need some data accessibility and governance. So the interested people as a practice can have access to the right data, and not have access to data that by law or by some other restrictions they should not have access to, all the way to deployment practices. And we're going to touch on some of these points throughout this presentation, but it's important to have the big picture in mind, as opposed to seeing it as a tactical problem solving tool. You may ask then, okay, so how do we start? You always want to start from a sharp question. So what do I mean by a sharp question? It's not about good or bad. Bad questions, obviously, I don't want to spend time on that. Questions are good when they help the business move forward. I'm talking about questions that are not specific enough, and that's what the meaning of sharp is. So, for example, you see this example we have here. And it actually happens a lot. The higher level you go in the hierarchy of your organization, there are questions like the not so sharp one here. It's a good question to improve the top line, but okay, how? And this is not at the level that you can put in front of your analysts and your data scientists to try to solve. It takes a number of steps. Your subject matter experts typically have to jump in, and it takes work. You have to accept that and admit that, and carve out some time and resources to translate these high-level business questions to more tangible business questions, and eventually a corresponding or supporting technical question that your data science team can tackle as a sharp question, as a very clear question they can tackle. It's always good to start small. We just talked about having the big picture in mind, and trying to see this as a organizational capacity, but you don't want to boil the ocean right away. It's always good to think large but start small, because if you start big and then fail, which is actually quite likely, then the consequences of failure can be really big. It can set back your whole program by literally years in some cases. All right, so let's say you start small and you have some buy-in from your executives. Now, there are different types, different buckets of analysis you can do. And I can give you a number of examples to drive the point home. Kamyar was earlier asking me to mix in some examples, and this was one of my responses to him, that hey, I do have some examples. So here are some examples that hopefully connect with you guys. So some of the types of analyses in your work can be purely exploratory, and even though some other types are predictive or causal, actually in most cases, regardless, your analysis starts here. This is when you start to look at the number of days in which the set point was never reached, right? So for example, you have this heater or set of heaters in a large building, so energy consumption is of your concern, and you're trying to, I'm not even going to say solve a problem. You want to start with the question, should it even be a problem that we spend our resources on and tackle? And it starts with, is this even a problem? So you explore your data. The other example is, what's the average sales amount for certain customers? You start with exploring your data to then see if there's a problem or not, or there's an opportunity to grow or not, and if yes, where and how, to guide your next steps. Moving on to the middle bucket, predictive. This is where your pure purpose is prediction. And here's another good example for you. This typical differentiation between prediction and causation. A very good one that I always smile at is, if I ask you to predict if an individual can read or write, and the input that I give you, the predictor, is his or her shoe size, it's a great predictor. But you cannot buy a 2-year-old kid, a large shoe and expect that kid to be able to all of a sudden read or write. So, so you want to be always careful about that. So, but there's a lot of value in many cases, like which features can predict the power usage on a certain day, and back to our power consumption example, which can have real ramifications for your the cost of power or your maintenance schedule. You know, to know where and when you should schedule your maintenance. And then causation. Obviously, you know, at the end of the day, in many cases, you wanna take actions to impact something that you care about in your business. And this is one example. You know, what causes rates to click rates to go up? Is it the shape of the ad? Is it its size? Is it the time of the day? Is it their algorithm? Is it the content and what it advertises? None of the above. So, which is actually a pretty challenging problem to solve in many cases. And now to talk a little bit more about one of the other pitfalls that you need to be careful about, you know, prediction versus influencing or controlling. You have to know that in advance. I've seen some real examples where in the field of manufacturing, where the whole team, you know, somebody didn't do their job, and there was a gap in understanding of the meaning of the features. So the actual goal was to control something, but it was lost in the chain of translation of the problem. After weeks of problem solving, the data science team came back and solved for the thing that the business cared about, and said, yeah, you just move this thing, this other variable, and then you can move up or down this other variable that you care about. Only to realize that that knob that they came up with, that's not something you have control over. It's an internal variable in the control system. It's not exposed. So they were basically back to drawing board, a lot of time lost. So that's why you want to know the goal of your problem beforehand. All right. So Rich, you know, that's actually a good segue. How would you build your team? What kind of personas you need in your organization and in your problem ecosystem, so you're set up for success? You need some data engineers, because these are the people who know mainly at the two ends of your problem. In the beginning, to give you access to your data, and they're the ones who know where data sits, what are the governance rules and requirements. And on the other side, when the model is built, they're the ones who can deploy it in a way that's consistent with your IT, and it doesn't bring down other production systems. So they're critical. Data scientists, obviously, I don't need to spend too much time on that. They are the ones who, you know, get raw data and build models and deliver value. So you need subject matter experts. I cannot emphasize this enough. So, you know, it's easy for you and I in this conversation, it makes a lot of sense, but you'd be surprised how many times, and I'm putting it in quotes, the smart data scientists, they get too cocky and they're like, yeah, we understood it, just give us the data and give us 2 weeks and we come back with the solution. It's almost guaranteed to fail unless the data scientists are familiar with the line of business. They can very easily solve for the wrong problem or solve for something that's not even doable. 1,000 things can go wrong if your subject matter experts are not part of your process. And then you need management buy-in, not only for facilitation and resources to be carved out, but also for buy-in. Buy-in is very important because you need access to compute resources, you need access to data, you need access to people's time. And at the end of the day, hopefully the models, the results are to be deployed and implemented somewhere. And that takes management buy-in. So you want to have that before you even go in. So, so you actually move the needle somewhere. And because of this ecosystem of different personas, And by the way, these are personas. You know, one person can, for smaller problems, fill in 2 roles, or for larger problems, you can have multiple people in 1 role. So, so those are personas. And because of that, you want to have some sort of project management communication in place. Ideally, the key points, the definition of the projects and requirements in black and white, so everybody knows from the get-go what they're signing up for, and everything gets documented. All right, so when we talk about buy-in from management, and when we talk about subject matter experts, explainability of the models is a key factor. And what does it mean? It means you can build a model. Let me give you actually two examples side by side. You can have a model that basically prescribes what ad to show to this user on the web with such and such observations. That's fine, you know, as long as the model does a good job and you get good click rate, you know, it's basically it. You know, nobody's going to ask you for too much details why it works the way it does, as long as it works well. Now compare that with a situation where we have a control system. It's a large tank, and your algorithm is gonna make some decisions about set points or certain inputs to the tank. And if it goes wrong, the whole thing can blow up. So you cannot say my model works and it works fine, but I don't know why. There's no explanation. There's a lot of different viewpoints depending on the use case. Different models have different explainability characteristics, and you have to be aware of that and sometimes accept a trade-off. So the graph you see here, it's a very simplistic view, but it drives the point home. Sometimes it's actually very advisable to sacrifice some precision in the interest of better explainability. And typically, you know, simpler models are more explainable, even though the quality of prediction can be lower. You can build more sophisticated models with better quality, but they get less and less transparent. They get more opaque, more gray box and black box models. So you have to be aware of the needs there as well. Another dimension that is not on this graph, but it is very related here, the more complex models that can give you very good precision and quality, you have to know how much compute power and technological resources they take. And that might grow actually very quickly for some of these super sophisticated models. A real example, you might have heard about the Netflix grand prize or challenge, I think around 2009 or 10, to basically predict the movie ratings by Netflix users given a large data set of prior ratings. And it was a big marketing vehicle for Netflix. It was probably one of the, maybe at the time, the biggest hackathon ever, or challenge, I don't know, but it was up there. $1 million prize, there was a winner, it was announced, everything was fine, but in reality, Netflix never used the winning model in practice. Why? Because there was so much compute power needed for this thing to go in production that actually it would more than outweigh all the savings by the extra precision. So basically the takeaway out of the slide is precision is sometimes the only thing people think about. It's far from it. You have to think about explainability, cost, and some other factors when you choose your model. So I'm going to pass. We covered a lot of ground about the team and what things you should care about. I'm going to take maybe just a few minutes to introduce this framework, which is called CRISP-DM, short for Cross Industry Standard Process for Data Mining. It's a kind of a mature meaning it's been around for maybe 10 days. The DM, data mining, suggests that it was coined when data mining was the hot phrase of the day, maybe, I don't know, 10 years ago. But so aside from the name, it's a great framework. There are some other ones in the industry as well. They're more or less similar. So it's not about the details of this model, CRISP-DM. It's more about the thought process and the framework. So if you take this and try to apply this, it's a great framework to actually help you go through everything that I just talked about, and forces you to answer the right questions and think about the right things. And right out of the gate, what I would point out is look at all of the back and forth arrows and things that go back and the circle around the whole thing, which basically your takeaway is the whole process is far from a linear process. You should expect a lot of iterations. You should expect things to fail, and then you go back to your business. And then even after one iteration, the whole thing repeats. So I'm gonna go quickly through these phases and map it to basically what we talked about. So the first phase, you start from your business understanding, what matters to your business, and then map that to your data. Make sure you have supporting data to solve the problem. It forces you to think about implementing it in business. What exactly it is going to change, and engaging with your subject matter experts. And we talked about the myths and also the risk of not thinking about the bottom line impact. Quick, in case you're new to the concepts, a model is basically a representation based on data, based on observations that you make of a physical phenomenon, and then you say, okay, based on these observations, this is the digital model of this physical phenomenon. So I defined that to talk about building the model. This phase, basically what you do after you made sure that you understand the business requirements well, you go in and start building your model. And as you see, data preparation and modeling go in hand, and you iterate. Sometimes you need more data, you go back. What can actually go wrong if you're not careful? We talked about control versus just prediction, and also you do something, you make assumptions that, okay, we are going to use this data set, and then when you want to deploy your model, you realize that actually in production environment you don't have access to that data. So that's a pitfall. This is the evaluation phase. After you build your model, you have to evaluate that with your business owners. You go back and say, look, this is what we built. Does it still make sense? Is it the problem you asked for us to solve? And don't expect it to go through the first time around. Oftentimes they say no, or they say, oh, this is great, but having seen that, I have 3 more ideas, so go back and add them. It's very typical. It happens all the time. It's the most important thing is to close that loop and make sure you get the sign-in, because you need them to then eventually deploy your model. Speaking of which, you basically go to your data engineers, typically IT organizations, and you basically hand over your model. And different organizations have different platforms or requirements. Sometimes in-house, sometimes you leverage cloud offerings like the likes of Amazon or Google or Microsoft or others. But regardless, that goes into your production system. The requirements are different. It has to run all the time, or depending on the requirements. Then your development, that's why you need your IT and your data engineers heavily involved there. And then one factor, I close with this. So a lot of these nuances of different models and cutting edge neural networks and things like that, they get a lot of press, if you like. Rightly so. I'm not saying they don't deserve it, but something that's often overlooked is this importance of reproducible work, meaning if you solve it once, you have to assume that you're going to do it again and again and again, like any other software product. It's even more challenging because you have now software and data, and the physical systems change, so data changes, governance regulations change all the time. So everything you do in your processes, make sure that you build it for repetition. And there are actually some more and more upcoming platforms like Jupyter Notebook is a small piece of it, but there's more and more like Kubernetes and other automation techniques that help you achieve that. And that big circle around the whole process basically points to the need for reproducibility of your process. And with that, I'd like to thank you again for listening to me for this presentation. And I'd be happy to hear from you on LinkedIn and connect with you. And I'd return it back to Kamyar.
Thank you, Ahmad, for sharing your knowledge and your insight. It was very organized and it was very well presented. Thanks a lot for taking the time to educate our audience. So maybe we can have some follow-up conversation about the slides.
Sure.
So there's a lot of interest in trying out AI projects to see what's the potential for the companies. And here we're talking about established companies who are their core is not AI, so it's a different strategy compared to, for example, startups who are AI first. So the whole thing is, in those startups is built around AI. We're talking about companies who want to see what's the benefit. So your recommendation was for those companies to start small and see what kind of benefits they can get, maybe try different use cases, and basically see what kind of benefit they can get, and then double down on the projects that work, right? So
yeah,
that was
You're right, and the hype, the flip side of hype is big failure. So as much interest as some people might have in organizations about the potential of what AI or data science can do for their organizations, if they're not rooted in reality, they can turn into actually big non-believers and go into the camp of let's kill it. It was all hype. So not only starting small, finding that good potential is critical to make a fast and quick and ideally visible win. It's also important maybe as a softer factor to find the right people. You can after a few conversations, you hopefully want to start from a business owner who you can be more open with, and you can gauge how open they are to risk, how patient they can be to maybe the first round doesn't work, let's give it another chance. It goes a long way. The wrong business stakeholder can set you back or actually cause the whole thing to die, the whole program, because they get disappointed and their feedback to your CEO or your CTO is this whole thing is a hype, so forget about it. So yeah, it's very important to take the first step or first few steps very carefully.
Okay, perfect. And one of the things we're trying to do here with these videos is to highlight the use cases of AI. So that's one way for people in different organizations to understand, what's happening in other companies, in other organizations, what kind of use cases is doable or possible, so they can start thinking of, what kind of small projects they can start working on and implementing. So I think it's important to kind of organize and summarize these use cases and highlight it to companies. So that's part of our mission here with these videos we are creating.
Yeah, absolutely. And it directly goes back to our first point. We had it on, I guess, slide one, or the first one out of definitions. It's all about value. So you're absolutely right. And it's not necessarily an easy thing to pin down and say, okay, this is a point of value potential for data science for a company. Sometimes that very thing, before even trying to solve the problem, even identifying that problem can be a mini project of its own. Takes some creativity, takes some leap of faith in some cases, because the managers, the leaders, they have to agree and accept that there's enough potential to let their resources spend some time to brainstorm. And if you tell me if you're interested, I can quickly mention a few examples from different verticals.
Yeah, sure.
Yeah, so I can, based on my personal experience, I can talk about a few different verticals. If I start from my current job at Cisco, a huge opportunity is in the area of where you have a small market or lower market that you don't have the resources, or it doesn't make business sense to spend a lot of man hours, human resources on managing the account, quote unquote, or customer success. So there's a lot of room for opportunity to digitize and automate that customer success pieces or steps. It can be service, it can be renewal, it can be upsell. Bottom line, the success of your customer that buys loyalty of your customers in an organic way. Especially if your business, assuming you guys are the audience, you come from a more established, older company, chances are you're sitting on profiles of a lot of customers for a long time. So it checks two boxes for good meat for data science or AI projects. So you can actually inject data science or AI in your the life cycle of your customers, but it has to be very delicate. It has to be purposeful. It's again back to the sharp versus not so sharp question. You cannot say I want to make my customer life cycles smarter, good, but what? So you have to spend the time. It takes work. Do the homework and find those spots where you can say, oh, this email campaign that we are sending out, we can make this smarter based on some analytics about the customer. Another huge, it's actually a combination of different verticals in heavy industries and manufacturing world, which is my last job. There's actually a lot of low-hanging fruit there. If you think of like the world of social or online advertising as pretty matured, and there are clear winners in the market, it's very hard to break into that market. If you go into the likes of pharmaceuticals or chemicals or oil and gas, metals and mining, these kinds of industries, they are mature companies, so they've had the same challenges for many decades. Their processes and cultures are not necessarily built for data. Data is an afterthought. So by the same token, so that's the challenge side of it. The flip side of the challenge is opportunity. In many cases, I've seen firsthand some really simple, like just gather the data, do some exploratory analysis, turns into huge amounts of benefit and a profit for the business, typically in the bottom line, because the processes are in many cases just heuristic and old, and data can make them can shave off significant amount of costs. So in general, those manufacturing verticals, they are ready for a lot of low-hanging fruit, just harvestation.
Yeah, absolutely. Thanks a lot again. This was a great conversation and presentation. I really enjoyed it and learned a lot. Thank you for your time.
Thanks for the opportunity.
All right. Bye, everyone.
Bye now.